Hello everyone, we are Team 26. Let's start our presentation. In the presentation, we introduce our pipeline and result briefly. After that, we explain our reflection on the project and finish our presentation. This diagram is an overview of our pipeline. First, new data is created by merging collected data and existing data. After that, this data goes through processing module to create the new trained data set. This process is repeated periodically to keep the data set up to date. Using this data set, we train a new model. And with this model, we provide our recommendation service. We also monitor and do versioning our model by performing offline and online evaluation. This figure shows how the data is pre-processed before it is used for training the model. We get the data from Kafka streaming interface. We can get the information of the users, movies, and the ratings the users gives. As the data accumulates, the system updates the version of data to facilitate management. We train the model with our information related to the user, movie, and rating. Our recommendation model is SVD++. Finally, the model recommends 20 movies according to the user ID. It is reflected to the Kafka data streaming interface so that we can check if the model works well. The system is monitoring the offline evaluation and online evaluation. For the offline evaluation, accuracy, precision, R2, RMS, MAE is measured. For the online evaluation, the recommendation watching ratio, which indicates how many times the user has watched the movie since the time when the recommendation was made to the user. The system can develop the model based on these evaluations. It means that there is also the model versioning process as well as the data versioning process. It can reflect the evaluation result. Whenever the virtual machine is on, we are able to take requests and return the corresponding recommendations. In the portal, you can see that it outputs movies that correspond to the user ID. Also, we made our model monitorable through Grafana. This metric includes latency, memory usage, and our custom metric RWR as well. We also monitor if user watched our recommended movie to reflect this history to the future recommendation, although it will only be valid when the user left ratings for the movie. For fairness issue, we also check skewness of the data in the processing level so that our model did not get biased.
Now we are going to discuss reflection on recommendation service. Our biggest challenge was how to monitor the deployed model. We proceeded without much difficulty until designing and implementing the basic infrastructure up to milestone 1. However, when we dived into making the monitoring, we were not sure how to evaluate the model. So first, we didn't clearly decide on a metric and just rushed into implementation. Meanwhile, in the middle, we had to change the metric once. As a result, we had to restart the implementation from the scratch. What we realized here was that we needed plenty of brainstorming prior to implementation. Anyway, we eventually found out how to measure the quality of our model. We defined our own metric, recommendation watching rate, RWR score. This score is a value of the timing of watching the recommended movies divided by the time spent on watching the entire movies. It indicates how much the user liked our recommendations and preferred to watch them. It was also the issue to accumulate telemetry data accordingly. In order to accumulate data, we needed a data structure properly defined and an operation to use that data structure. So we defined a per user directory and collected data in that structure. And then we defined a according operation to extract the RWR score from that. Summing up, it was quite challenging, but we were glad to finish the monitoring part with a full score. During the project, we made several specialized teams to avoid having to study multiple tools to achieve the goal, that is, to focus on one part. For example, a team in charge of monitoring and load balancing only, a team in charge of A/B testing only, and a team in charge of version check and update only. Since all the team members were active in trying out new tools, which means no preference for work, it was a big advantage to have no friction in distribution. However, because of the distributed team structure, feedbacks on the report written by other teams were insufficient. Milestone 2 was completed one day before the deadline. Due to tight time, it was difficult to accurately check the contents, which led to the incompleteness of the report. What we lacked was the time. Having everyone following the same curriculum is a great advantage in scheduling appointments, but the high load of the curriculum has been the burden. Additionally, we need to make tutorials or explanations documents to inform other teammates. This is because most of our co-works between the teams were in person, caused alienating teams that are not involved in the task. And this is the end of presentation, and thank you for listening.